So let's see. We get f of x1 minus 9 over x1 minus 3, right? And then still, right, same thing. x1 goes to 3. Okay, but that doesn't seem good enough yet. But let me go down here. Anything else we can write? Anything else we can simplify? Hope this works. I hope I'm not doing this wrong. But x1 minus 3, still 9. Can't really do much with that. But what? This is x1 squared. Right? Okay. Okay. Yeah. Is that right? Okay, so now what do we do? This is a limit problem, right? If you don't like the 1 there, just think of this as a limit problem. If you don't like the 1 there, you just erase the 1. Just a limit problem, right? You could just get rid of that, that, that. So it's a limit problem, right? So how do we do this? What? That's one way. So he said, just start putting in values. Remember, that was the basic way that we did it. He said put in values that are close to 3, right? Like put in 3.2, 3.1, 3.11, I'm sorry, 3.01, 3.001, right? That's what you're saying, right? You close to it, yeah, that's good. That's a way to do it. But there is another way to do it. Now, I didn't make much about this, but maybe this is not a bad time to say this. Well, what is x? Can I just forget about limits? What is this? What? X plus 3. How did he do that? He factored the top, right? Right? It turns out you can factor the top, right? It's what? X plus 3, X minus 3, right? Right? Now, I didn't make too much point of this before, but maybe it's worth saying now. Well, we can cancel it. We say in algebra class, we're allowed to cancel these, right? So we would write this, right? I'm sorry, x plus 3, right? We would write that, right? In algebra class, they say that's right, but it's not quite right. Because this is not exactly the same as this. Why not? It's not, because this one is not defined at 3, technically. Right? But this one is certainly defined at 3. So not exactly the same. Right? A little bit different. Slightly different. Okay, so this one, what's the graph of this look like? Y equals x plus 3. What's that look like? That's just a straight line, right? That's just, here's 3. Just like that, right? But this one is the same as this one, except at one place. Where? When x equals 3, this is not defined, whereas that one is defined. So at 3, this one is just part of the straight line. But this one, actually, we have to put a little circle. Right? So they're not exactly the same, but they're nearly the same. Okay? Now the question, I might have lost our train of thought, but remember we're doing this. Okay? We're doing this. So, what can I do here? Well, we just said that I can just, I can just write it as what? X plus 3. Now that's technically a little tricky, because I'm working with this one, right? Is the limit of this one the same as the limit of as x plus 3? Yes. Right? The limit here is going to be the same thing that you would do if this was actually the function x plus 3. It's the same. So we are allowed to do that. We don't have to worry about that problem that we said there's a little circle there. We don't really need to worry about that. So I can do this. And now it's even easier to do. Now it's a super easy limit problem. Why did I do this? What was I trying to do? What are we trying to do? Trying to find the slope of this red line. And we got it down to this question. But this is easy to do. What is the answer to that? 6. Okay? So we did it. What did we estimate the answer was? A rough estimate. 7. But that wasn't the answer. But what do we get here? This is apparently the truth. Right? We kept working with it. We started with this. We started with this. Right? Actually, we started with this. Then we interpreted it for our specific question. This was for any function. Right? But then we said, let's do it for x squared. So we have to, put in x squared. And we want to do it specifically at x squared where x is 3. We want that slope. So we had to fill in all this stuff for that specific case. Means we had to use the function f of x equals x squared. And we had to put in 3 for x0. So we started to do that by putting in 3 for x0. Then we said, what should we do with f? Well, f is x squared, so we did that somewhere. Here somewhere, here, and here. Right? And then we did the limit, and then we were able to simplify the limit, and then we got the answer. And so we did get the slope of the red line. Okay? So the slope of the red line is 6. Okay? Everyone get it? All right? So that's a big accomplishment. Because how would you ever do that? Right? You only have one point. How are you going to get the slope? It's almost magic. Right? You can't get slope without 2 points, but we did it. Using this kind of vague or kind of mysterious concept of limit. That's the thing that did it. Okay? Then let's get, I think somewhere a week or two ago, I told you that if f of x equals x squared, then the derivative was equal to 2x. Do you remember that? And this is, by the way, this is called the derivative, this thing right here. In general, this is called the derivative for any function f. I want to now show that specifically for this function f, that this will happen. And if that's true, if this is true, then this tells you the slope everywhere. That's what the point, this is supposed to tell us. And we just found that the slope was what? 6, right? Where? When x was equal to 3. Does this work? Yeah, when you put in x equals 3, you do get 6. Right? We just found that this formula is true for one point. Right? Just when x equals 3. But I want to prove this formula in general. Okay, I want to start out with this, use this, and get 2x at the end. Okay, and that will show that this thing is called, this is called f prime. This is called the derivative. Okay, so I want to show that when I do that, for this function, I get 2x, because I told you that it was 2x. Now I can prove to you that it's 2x. Okay? Does it make sense? Okay. Oh, how do I do it? Tell me what to do. So let's write down, what do we want to show? Okay, does everyone see this? What's this? What's this whole thing, this box called? Called f prime, or the derivative of f. Okay? Okay, now, so what do I want to show now? I want to say, so show that if f of x equals x squared, then f prime equals what? 2x. I told you I told you these formulas before, right? How to do this, but now I want to prove it. One of the formulas I told you was that this should be 2x. Right? You remember that? In general, what was the general situation? If f of x was equal to x to the n, then f prime was equal to what? You remember that? It was equal to n x to the n minus 1. Okay? But I don't want to prove it in general, I just want to prove it in this case. So if f of x is equal to x squared, I want to prove that this is true. Okay? How am I going to do it? I just use this. And what do I put in specifically? I put in specifically for the function f, I put in x squared. And that should work out. Once I do that, I should end up with, finally, after I do all this, 2x. It's going to simplify out to just 2x. Okay? Do you understand what we're trying to do? This is called the derivative. I told you that the derivative of x squared was 2x. Now I want to prove it to you. So I have to put in x squared into this and get 2x out. Okay? That makes sense? Okay, so tell me what to do. Tell me what to do. What should I do? I want to show this. I just want to put everything in here and finally end up with 2x. So let's do it. So f prime just put it on that side. Okay, so what should I do? Tell me what to do. Just put everything in here. And I want to get out 2x, so just start to do it. So I don't want to do this part first. This is kind of crazy and hard. I just leave that as it is. So I'll just leave that for the time being. x1 approaches x0. Okay, so I won't do that part now. Okay, now what can I do? Oh, I can put that line there. Now what can I do? So the bottom part is going to be the same, x1 minus x0. Okay, what's the top part going to be? Well, if we're talking about this function, then what is this? X0 squared, right? Very simple. Just x0 squared, right? So let's just put that in. All right. And what is this part? X1 squared, right? Very simple. Okay? Now, okay, let's leave it and keep going. Okay, so now what? Now we could try and do the limit, but we saw that there was a nice thing that happened before, and actually this is the same case as before. It's just that we're not using a specific number anymore. We're not saying specifically at 3. But, so what nice thing happened before? From here, what happened? I factored and I canceled. So the question is, will that happen here? Yeah, right? It's going to happen again. Really the same problem we did before. We're just not doing it at 3. So what's the top part factor to? You took non-fundamental math, so that means that you already knew fundamental math. Anyway, you of course know how to do this. This is 9th grade algebra. Maybe 10th grade, 9th grade, I don't remember anymore, but it's basic algebra. So, what do I do? X1 plus X0, is that right? On the top? Yeah. And what's on the bottom? Same thing. We don't change it. Okay. And now what? Cross out. Can I cross it in here? Let's see. That and that. So now, what do I get? Lim x1 approaches x0. And I just left with what? Okay. What do we want to get as our answer? We want to get 2x. Now, we have all these subscripts, which we don't really need. But anyway, what do we want to get in our answer? 2x. I mean, why do we want to get that? Because I told you that was the correct answer. This is where we discover that it is the correct answer. Right? We don't know that we want to get 2x. Right? We're actually discovering what it should be, what it will be. Anyway, what do we do here? Well, as x1 goes to x0, what's the variable here? This is a little bit confusing now. The variable means the thing that's changing. So what's changing here? Let's remember this notation again. If we write limit as x goes to 8 of x plus 7, what's changing here? X is moving, right? Right? X is moving, right? This says x is getting close to 8, right? So this must mean that x1 is getting close to this is the constant. Okay? Just like 8 is the constant here, right? Okay, 8 is not moving. X is moving towards 8, right? That makes sense? So this thing must be moving towards this thing, right? Right? So let's call this, let me just switch. Let me just drop this and drop that. So think of x as the variable. X is the thing that's moving, right? Okay? Because that's what this notation demands. It demands that this is the thing that's moving towards this. It demands that this is the variable moving towards this constant. Okay? Right? Just like this is the variable moving towards this constant. That's what the notation means. So now what? It means x is getting close to x0, right? So that means I can just fill in, instead of x, I can put x0. right? So what do I get? 2x, well, I get x0 plus x0. This one is the thing that's moving, and it's moving towards x0, so it becomes x0, right? So I get x0 plus x0, or 2x0. And that's really what we wanted to show. The subscripts look a little bit confusing, but it's just that we wanted to show that if this is the function, then 2x is the derivative. How do we do this again? This is the definition of the derivative, and we just used it with the specific function x squared. We put, this is the definition for all functions. So we want to know the result specifically for x squared. What do we get? So we just filled in, we used x squared. Here, this becomes x1 squared. Here, this becomes x0 squared. Then we just finished it, and we end up with 2x. So that's why I told you that the derivative was 2x, or x squared. But it's not like just the derivative is 2x. No, the derivative tells you the slope. Right? So now we know the slope everywhere for a parabola. So if I want to know the slope at 3, I know it's 6. But if I want to know the slope at 8, I know it is what? When x equals 8, the slope is 16. Right? And if I want to know the slope at -5, before you